Ladies and gentlemen, boys and girls, children of all ages, today's lesson is going to be a quick review of subtracting mixed numbers with borrowing. Now, we've learned to subtract mixed numbers where you could change them both to improper fractions and do it, but we're going to look at another way that it can be done. So if we have the fraction 7 and 3/8, 7 and 3/8, and we subtract 2 and 1/2. Logan, can I subtract this the way they're currently written?
Yes. No.
You're not Logan. Yes, good. Tell me the answer for the fraction. 3/8 minus 1/2. Can't do it. You have to have a common denominator. So can we subtract these the way they're written, Logan? No, why not?
It's harder to do it instead of subtracting it horizontally.
Or we need a common denominator. Jacob J.
I knew that.
Jacob J. What would our common denominator be? 8. I can change both of these fractions so that they have a denominator of 8 without changing the value. Alright, so Jacob J. This would be 7 and how many eighths?
3.
3/8. Jacob J. This would be 2 and how many eighths?
4.
4. And we are subtracting. So Jacob J. Can we subtract it now they have common denominators? No, we cannot. Because if Logan has $3 on his desk, Jacob J. cannot go take $4 from him. He only has 3, so you can't take 4. So we can't do 3 subtract 4.
Give me back my money.
But let me ask you this, Isabella. This is a serious question, okay? We're going to pretend.
Okay.
All right. So Isabella, you go to the vending machine. You have a $1 bill and 4 quarters in your pocket, but you realize the machine doesn't take dollar bills. It only takes quarters. What do you do? I use the quarters, but what you're buying costs $2. Change the dollar to quarters, right? Then we have enough. So what we're going to do here, and when I give you a test on this, and I see that you've just been talking and playing, I will feel really bad when you don't get a good grade. So we're going to have to borrow one whole. So I'm going to borrow from that whole number, and now I have 6. It's like taking that dollar, and then we're going to trade it in for quarters. We're taking this whole number, and we're going to trade it in for a fraction. But Logan, let me ask you, since you are enjoying talking today, let me ask you, I need to add a fraction that equals 1 to 3/8. Can you think of any fraction that equals 1 that I could add to 3/8? First, tell me what a fraction that equals 1 looks like. Heaven, what does a fraction that equals 1 look like?
Say something.
Matilda!
It has one whole number on the top and the same on the bottom.
Good. It has the same numerator as denominator. So 5 over 5 equals 1. 93 over 93 equals 1. So one of the Sydneys. What should I add to 3/8 that equals 1?
8/8.
8/8. Can you tell me why you picked 8/8?
Because it's a whole.
It is a whole, but so is 17 over 17. Why did you make it 8 over 8?
Because the denominator is 8.
Good. In order to add fractions, we need to have a common denominator. That's why we pick 8/8. Now, one of the Sydneys. 3/8 plus 8/8 is 11/8. So now we have 6 and 11/8, which is the exact same thing as 7 and 3/8. And I can subtract 2 and 4/8 from that. I can subtract 2 and 4/8 from that. So Logan, 6 and 11/8, subtract 2 and 4/8 equals... Subtract the fraction first. 11/8 subtract 4/8.
7/8.
7/8. And my whole number subtract?
4.
4. So I have 4 and 7/8. Logan, can you simplify 7/8?
No.
Are you sure?
Yes.
You're sure. Good. That's exactly how it's done. You borrow from the whole number, borrow 1, add 1 as a fraction to your fraction, and that's a lot of times easier than changing them both to improper fractions and then changing them back to mixed numbers. So let's take, let's see, minus, we have 5 and 1/6. Subtract 3 and 3/4. Macy, can I subtract these? How they are currently written?
No.
Why not, Macy?
Because they don't have the same denominator.
They do not have the same denominator. Do you know what the common denominator would be, Macy?
Yeah, I think it's 12.
It is 12. So I'm going to have 5 and how many 12s, Macy?
2.
2 12s. 5 and 2 12s. Subtract 3 and how many 12s?
3.
Would you multiply by 4 to get 12?
3.
Okay, so that's 3. 9. So we have 5 and 2 12s. Subtract 3 and 9 12s. Carlos, now can I subtract? No, why not?
Because the 2.
The 2 is smaller than the 9, so I can't take 9 from this 2. Okay? So what do I need to do, Carlos? Good. I'm going to borrow from the whole number, and I'm going to make this 4 and something over 12. What am I going to add to 2 12ths? I need a fraction that equals 1 that I'm going to add to 2 12ths that's going to make it easier. Andrew, 12 12ths.
12.
Because when I add fractions, they have to have the same denominator. So it's easier just to pick the denominator that's already there. And a fraction that has the same numerator as denominator equals 1. So Andrew, what is my numerator? 14 12ths. I have 4 and 14 12ths. Subtract 3 and 9 12ths. And I get what? Alyssa? 4 and 14 12ths. Subtract 3 and 9 12ths. Gets me what, Alyssa?
1 and 5 12.
1 and 5 12ths. Alyssa, can I simplify 5 12ths?
No.
Man, there's a lot of Alyssas in here. It's like Gremlins, where they eat after midnight, and then or is it when they get in the water? It's when they get wet, and then there are a whole bunch of them there are. You're correct, Alyssas. You cannot simplify 5 12ths. So my answer is 1 and 5 12ths. Boom, shakalaka, peace out. God bless, love you. Do something kind today. Subscribe.